It's Nick here from NickBricks, and today I will be giving a math lesson. I will be teaching how to use division patterns with decimals. So I will be showing you how to divide like 179 by a power of 10. So 179 divided by 10 to the power of 0 is 179. 179 divided by 10 to the power of 1 is 17 and 9/10. And then 179 divided by 10 to the power of 2 is 1 and 79/100. And then 79 divided by 10 to the power of 3 is 0 and 179 thousandths. So that's called a division pattern right there. And that is with decimals, so you can see the decimals go through there. And you do that for all of these. So now let's do number 5. This one is with 1, 10, 100, and 1000. It's not the power of 10, but it is about the same as the power of 10. Because the 0, the 1, the 2, and the 3 all mean how many zeros are on the end of the 1. So like So like 1 add 3 zeros is 1000. So that means 1000. 1 with 2 zeros behind it is 100. So that means 100. And then 1 with 1 zero behind it is 10. And then 1 with no zero behind it, because that's 0 zeros, is 0. So basically you're multiplying it by it's just 1. So you're multiplying it by 1. So you're dividing it by 1, or you could be multiplying it by 1. It's the same with division and multiplication most of the time. So we're gonna go to number 5, like I said. 18 divided by 1 is 18, because that's just how division works. 18 divided by 10 is not 1.8. 1 and 8/10. 18 divided by 100 is 0 and 18/100. 18 divided by 1000 is 0 and 18/1000. Now we're going to move on over to number 3. Sorry, I'm not going in order. This is Go Math Notebook, just so if you want to know what it's from. So 87 and 5/10 divided by 10 to the power of 0 is 87 and 5/10, because you don't divide or multiply by anything. So 87 and 5/10 divided by 10 to the power of 1 is 8 and 75/100. 87 and 5/10, sorry for the clock in the background, is 10 and 10 to the power of 2, which is 0 and 875 thousandths. And now we're going to move on to the problem solving in the real world. A local cafe uses 510 cups of mixed vegetables to make 1,000 quarts of beef barley soup. Each quart of soup contains the same amount of vegetables. How many cups of vegetables are in each quart of soup? So in this, you circle the 1,000, the 510, you'll underline everything around it, and then you'll box the question. And then, so the 1000 means that you're going to take the zeros, and that's how many places you're gonna like make a curved line. So like you take one place for 10, another place for another 0, and one more place. And that last place, you place your decimal, and then you add a 0 on the end if there isn't a number already there. So your answer would be 0 and 510 hundredths, or 0 and 510 thousandths, or it could be, if you drop the 0, 0 and 51 hundredths. And now number 11. The same cafe uses 18 and 5/10 cups of flour to make 100 servings of pancakes. How many cups of flour are in one serving of pancakes? So you do the same thing. You see the 100, you circle it. You see the 18.5, you circle that. You underline everything else, and then you box your question. So you take the 100, you move. Since that already had a decimal, you start from there. And then you go over one space and then another space for the 2 zeros. And then you have 0, 0, and 185 hundredths. Now when you get down here, you get to the explain how to use the pattern to find 35 and 6/10 divided by 10 to the power of 2. I wrote 300, wow, I thought that said 356. 35 and 6/10 divided by 10 to the power of 1 is 3.56. And 35 and 6/10 divided by 10 to the power of 2 is 0 and 356 thousandths. And to explain how you use the pattern, so the pattern is just like this. So this number 2, number 3, number 6, number 9, number 5, number 8, number 4, number 7, and number 1 are all division patterns. Whoa, that's the title. So division patterns are where it could start off with 18 divided by 1, then go to 10, then go 100, 1000, or it could do the power of 10s, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, or it could really just go into anything with decimals. It's really confusing, but it's math. So that's going to end off our episode today, and hope you all enjoyed. And this has been a math lesson with Nick, and goodbye, everybody.